Hello guys, welcome back to our channel. In this video I am going to discuss about inverse of a number. So this is not a multiplicative inverse, it is a problem statement given by some companies. What is the problem statement here? So before going to know the logic, first of all you are given a number with the certain constraints. That is, the primary key constraint is, if you take any number, that is, either it may be a 5 digit or 4 digit or 6 digit number, that number should consist of the, if it is a 6 digit, then it should consist of the 1 to 6. Then if your number is having the 7 digit, then it should consist of the 1 to 7 without missing any character, any digit, and there should not be any repetition. That is the first constraint. That is, whatever it might be the number's size, then that number should have from the 1 to that number size without missing any number, and it doesn't have any repeating values. So let us assume this one and let us take a break into the simple examples. So if I take a 5, 4, 3, 2, 1, yes, this is a valid because it consists of 1, 2, 3, 4, 5. So if I take the 1, 2, 5, 8, 7, 6, 4, 3, 4, then it consists of 1, 2, 3, 4, 5, 6, 7, 8. So if you observe here, 5 digit, so 1 to 5, 8 digit, 1 to 8. So if you take the 3, 2, 3, 1, 2, so it is also valid because 1, 2, 3. Like this, if you consider or if you take any number, that number should have the 1 to the size of that number. No repetition. If you consider this one, 1, 2, 3, 4, 1. This is not valid. Why? Because it consists of 1 2 times. 1 appeared 2 times. So we should not consist of the repetition. That is the first and foremost thing. Then if you are given that 1, 2, 3, 5, it is also not valid because this is a 4 digits, 1, 2, 3, and the next one should be the 4. But unfortunately we taken the 5. So that means this is also not valid number. So this is the first constraint they have given. The constraint is, if the number is the 5 digit form, then it should contain all the digits from 1 to 5. If the number is a 6 digit, it should consist of all the digits from 1 to 6. That is the problem first constraint. Now let us look into what thing we have to do. That is, we have to find the inverse of a number. What is this inverse of a number here? Here the inverse of a number is defined as, normally we will take it as a multiplicative inverse, that is another thing. But here the problem statement defines another definition for the inverse. That is a number created by interchanging the face value and index value of digits of the numbers. What does this face value and index value? I will tell you. Let us take this one. This is a number. Let us assume the number is 1, 2, 4, 3, 5. Now, if we consider this number, I will take a table representation. 5 digit. Yes. 1, 2, 4, 3, 5. So this is the particular representation. Now, if you observe here, 5 is in the 1's position, 3 is in the 2nd position, 4 in the 3rd position, 2 in the 4th position, 1 in the 5th position. So this is the way it has been taken. Insert left. Yeah, this is the index position. Index 1 we have the 5, index 2 we have the 3, index 3 we have the 4, index 4 we have 2, index 5 we have 1. That is face value. This is the thing they have asked. Interchanging the face value and index of digits of number. Interchange the face value and index of the respective number. Now this is the original number. Now they are asking us for the inverse number. What does this inverse number? It is nothing but interchanging the face value and index value. Now I will take this one. So here I have taken the indexes from 1 to 5. Now interchanging the face value and index value means, what is the face value here? 1. That 1 is becoming the index here. That means what is the respective index associated with 1? It is 5. So 5 have to come here. Then 2. 2 means 4. 4 have to come here. 3. 3 means 4. Sorry. 3 here. 3 means 2. 2 have to be placed. Next 4. What is the face value 4? Yes. What is the respective index? 3. 3. Then 5. 5 means 1. So the inverse number obtained is 13245. This is original number 12435 and the inverse number is 13245. So that means we have to change the face value to index value to the face. So whatever the face value 1 is there, that have changed in the inverse as the index. Whatever the index value 5 is there, that comes to the face value of the inverse number. Now let us take the example given here, 426135. Number equal to 426135. So we have total 6 digits. 4, 2, 6, 1, 3, 5. Now let us do the inverse manually. Original number and inverse number. So inverse number is, we have to do that face value as a index value as a face. Now what is the face value? 1. 1. What is the value associated with 1? 3. 3 have to be taken here. 2. 5. 3. 2. 4. 6. Then 5. What is the 5 here? Yeah, 5. 5 means the index is 1. 1. Then at the last we have the 6. 6 is associated with 4. That means the inverse number we obtained is 416253. Look at here. 416253. This is the logic of doing the inverse of a number. So for this we have to write a program. Now you have seen that this is the face value, this is the index value. Let us assume this face value as original value, index as the original position. In the inverse, this is the index is nothing but the face value. That means this is new position. Let us assume as the new position. Then face value is the new value. Now based on these things, if you observe that the original position, whatever the original position 6, 5, 4, 3, they are turned as the new values. If you observe clearly, original position becomes the new value. From this, can we interpret that new position has been obtained from the original value? Yes, that is nothing but it is the interchanging. Original value is coming to the new position. Original position is coming to the new value. So we can write it as the new position is equal to original value. So whatever the original value is there, that has been turned out to the new position. Then whatever the new value is there, new value is nothing but which was the previous original position. Original position. Now this is fine. This is fine. Now how can we take this one, or how can we convert this one into our program? So before going to do that one, first of all take this one 426135. I am taking the 426135 number. Now for this purpose we have to do that. I will take a table for making this one. So 426135. So this is my original number. Now I have to get the 5. For that purpose what I have to do? 426135 mod 10. That means I am going to get the answer as 5. So I am going to get the answer as 5 means it is a position or a value? Nothing but it is a value. So original, in the initial stage, original position will be 1, 2, 3, 4, 5. Then original value is nothing but when we perform the modulus operation by number, we are going to get 5. After 5, then we are going to get that 426135 / 10. So we are going to get this one with the as answer as 426135. So 426135. Then if we perform the mod 10 again, then we are going to get the original value as 426135. We are going to get the 42613 mod 10. So 42613 mod 10 means we are going to get the 3. Then if we perform 42613 by 10, then we are going to get 4261. Then again 4261 mod 10. Then we are going to get that 1. Then 4261 by 10. So we are going to get 426. Then 426 mod 10. So we are going to get the 6. Then 426 by 10. We are going to get 42. So again 42 mod 10. We are going to get 2. Then 42 by 10. We are going to get the 4. So 4 mod 10. We are going to get the 4 and then 4 by 10. Simply 0. So nothing more there. So whenever in the first position we got 5. Then in the second position we got 3. Then 4, 1, 6, 2. And then at the sixth position we got the 4. Now what is the task? This original value had to be converted to the new position. So new position and new value. Now what is the original value 5? Original value 5 should be turned it as a position number. That means if I take the original value as original value, then the new position like this, new position. Let us assume this is a variable name. New position equal to original values. So the 5 will be turned out as the new position. What is the position number? 5. So this is the 5th position. Now Again I am going to take that. Look at here. New value equal to original position. So new value equal to original position. What is the original position? 1, which is associated with this original value. So this 1 is going to become the new value. This thing. So we have completed this one. Now for the same thing, then this is a 3. 3 means 3 position here. So what it is going to take? Original position 2 here. Then 1. So 1 here. What is the 1? 3. 3 here. Then 6. 6 here. Then 6. What is the 6 associated with? 4. 4 will be coming here. Then after that, what is there? 2. 2 position is here. Then what is the value associated with 2? 5. 5 should be taken here. And the last one is the 4. This 4 comes here and the associated value is 6. 6. Now 3, 5, 2, 6, 1, 4. Now we got the individual values here. That is, the new values are nothing but the individual values. Now if you observe a keen and careful one, how can we calculate the perfect combo of this all these individual numbers? For example, let us assume that if the number is here, new value is here, if the position is this, so can we take inverse as inverse, that is initially I am taking that inverse equal to 0. So inverse place the new value into, if 4 is there, what is the output of this one? 416253. Output is 416253. So if we are having the individual digits 416253. So if you observe that for 4 we have to take the remaining things as the zeros. 4 we have to take remaining things as zeros. How can we take the remaining things as zeros? When we can multiply this 4 with the 10 power position minus 1. For example, when you got the 6th position, new value is 4. So 4, then we left with the 3, 4, 5. 5 spaces. How we are going to replace these 5 spaces? So simply, if you multiply that 4 into 10 power 5. What we are going to get? 4 into 10 power 5. So 10 tens, 100, 1000, 10,000. So 1 lakh. 1, 1, 2, 3, 4, 5. So if you multiply this one, we are going to get that 4, 1, 2, 3, 4, 5. 5 zeros have been occupied. Now if you take the 1, so after 4 we have 1. Then remaining have been empty. So then what we can do? 1 into the number of positions. The positions is the 5th position and the vacant position is at the 4 positions. That means 10 power number of new position, that is new position minus 1 if you consider this one. So here also the same thing, new position minus 1. So that is, if the position is 6th one, we have to multiply with the 5. If the position is the 4th one, we have to multiply 1 into 10 power new position. What is the new position? 5. 5 minus 1, none other than 4. So 1, 1, 2, 3, 4. 10,000. So the 4 zeros has been replaced here. Now next one, 4, 1, 6. That means 3 empty vacant positions. So 6 into 10 power new position minus 1. So what is the new position here? 6 into 10 power, what is the new position? 4. 4 minus 1, 3. So 6,000. Now 4 to 6, 1. So how many? 2 places left. So 1 into 10 into 10 power minus new position minus 1. So 1 into, what is the position of this 1? Sorry, 4 to 6, 1. 4, sorry, I am taking the wrong. The 4, 1, 6. 4, 1, 6, 2. 2 into. 2 into. So, what is the 2? 3. 3 minus 1? 2. 10 power 2. That is equal to 200. Then 4, 1, 6, 2. After that, 5. And 1 empty space. So, 5 into 10 power new. So, 5 into 10 power 1 is nothing but only 10. So, 50. The last one is 416251 equal to nothing. One's place. No need to do anything. Simply taking the 1 itself. Now, if you add this all the things, 4 5 zeros for 1. So, 4 1 2 3 4 5. Then we have the 1 1 2 3 4. 1 1 2 3 4. Then after that we have the 6,000. Then 200. Then 50. 50. Then last thing is 1. If we add all this stuff, we are going to get that simply the 416. This is sorry 3. This is 3. So 3 3. 416253. So is this the output we want? Yes. So to get the inverse, initially I am taking the inverse as the 0. So what I am going to do, every new value, whatever the new value I have obtained, I am going to perform that 10 new value into the 10 to the power of the new position minus 1. So for filling the remaining one with the zeros. So new value into 10 power new position minus 1. So this completes our particular problem. Yes, this is the logic only. That is, original values have to be taken into the new position. Original position should be taken into the new value. Now let us write the program. So first of all, we have to take a number n equal to int of input of enter a number. So I am entering a number. Then after that I am taking that original position. That is, initially the original position should start from the first position. So for that purpose I am taking it as the 1. Then again what we have taken for initializing the inverse, we have taken that inverse equal to 0. So inverse equal to 0. So while the number is greater than 0, because we have to iterate for the every position, that is from 5, 3, 1, 6, 2, 4. So for this purpose I am taking the iteration. What we are doing, we are calculating the original value as well as we are calculating the remaining value. So original value equal to number, whatever the number we have taken, mod 10. Look at here, this one. So to obtain this original value, we are performing the mod 10. Then after that what we are doing, we are going to take that this one. Original value, it is turning out to the original value is turning out to the new position. Look at here. Original value is turned out to the new position. Now 5 original is there. It turned out to the new position. one original position is there. That comes into the new value. So we have taken this one. Then after that, I am going to perform the inverse equal to inverse place, that is new value into 10 power new position minus 1. Then we are going to get this entire calculation. So this one, new value into 10 power new position minus 1. After that, for each and every value has been calculated, that is 5, 3, 1, 6, 2, 4. We have to increment the positions also. So we have done this here. For that one, what I am going to do is original position equal to original position plus 1. So for every time the original value has been calculated, then the value of the position will be incremented to store the other value. Now incremented, and to get this one, the quotient, what we are doing? We are doing the 4 division. That means n equal to n by 10. Print of inverse. That's it. Run. Enter a number 426135. 416253. 416253. Now run again. Enter a number. Any numbers we have taken? Yeah. 12435. 13245. Yes. So this is the inverse of a number. 2134 is there. 1243 we have to get. Again run. 2134. 1243, yes. 24153, yeah, fine. 24153. 24153. Yes, we got the same thing. So this is the inverse of a number.